So what is HashSet? Try to imagine the hash table without key. That becomes as HashSet. See, in case of hash table, the index will be generated based on the hash code of the key, right? And you have a unique key there. But in case of HashSet, the index will be calculated based on the hash code of the value instead of based on the hash code of the key. But in this case, the values must be unique. So duplicate values are not allowed in case of HashSet. But of course, the hash code may be duplicate. So there is a possibility of duplicate indexes generated based on two different values. So here the formula for generation of index is that hash code of the value modulo count of the elements. That means the capacity of the hash set at that moment. Always the capacity will be maintained as a prime number. The default capacity is 17. And if you keep adding elements to the hash set, the capacity will be automatically incremented. Here the capacity means the size of the internal array where the values are really stored inside the hash set. So internally, hash set has an array and memory will be allocated for certain capacity. So the size of that particular array is treated as count or size of the hash set. For example, you are trying to add an element called schools. So based on the value called schools, the hash code will be generated. Here the hash code of the string values will be automatically generated based on the predefined implementation of the getHashCode method of system.object class. So in the system.object class, there is a method called getHashCode, and that was overridden in the system.string class, which calculates the hash code based on the characters. So the sum of the ASCII codes of all the characters of the string becomes as hash code of the particular string. This will be done automatically based on the predefined implementation of system.string class. In case of numerical values, the same number itself is treated as hash code. And in case of custom classes, we have to generate a unique value. Generally, we will consider the ID as hash code. For example, in case of employee object, the employee ID is the unique value, so that can be considered as hash code. It takes up the hash code of the particular string, for example, schools, and the hash code will be divided by the size of the internal array of the hash set, that is considered as count of the hash set. The result value is treated as index. For example, we got the index as 0. So in the index position of 0, the element will be stored. By default, the next pointer is null. That means it doesn't refer to anything else. In case for some other element, if you get the same index, that element will be stored next to the previous, and the next pointer contains reference to the next element. Like this, there is a possibility of same index for multiple values, so they are stored as a linked list internally. So almost the same process happens in case of hash table also, but whereas hash table generates the index based on the hash code of the key, but in case of hash set, there is no key, right? That's why the index will be generated based on the value rather than key. And in case of hash set, values must be unique. In case of hash table, values may be duplicate, but key must be unique. And another difference is that hash set is a generic class, so you need to specify the data type for the value. It can be any data type, for example, int, float, string, or any other custom class. The benefit of HashSet is that retrieval time it's extremely faster because suppose you are looking for the particular value called painting. So based on the value called painting, an index will be generated at that moment and it goes to the particular index directly instead of searching all the previous elements in the form of linear search. So that is the reason it's extremely faster while retrieving. That means while checking whether the element exists or not. That is the benefit of HashSet. See, in case if you store the same values in the form of a list, suppose you are searching for a particular element, you need to perform linear search. That means you have to search all the elements top to bottom. But it's not the case in case of HashSet. So checking and determining whether the particular element exists or not is extremely faster in case of HashSet. So sometimes rather than storing the elements in the form of a collection, you want to make sure whether this particular element or object already exists in the collection or not. If that is your main intention, then you prefer using HashSet over the list class. Let me demonstrate HashSet in the console application. Here we require the namespace called system.collections.generic because in that namespace only we have the class called HashSet. I am creating an object for HashSet class and I must specify the data type of the value, what type of values I wish to store. In this case, I want to store the set of string values. So I am giving the data type as a string and name of the reference variable is messages. Of course, it can be anything. And I need to specify the same data type once again while creating the object. So the left hand side portion of the code will create a reference variable and right hand side portion will create an object for the HashSet class. By default, the HashSet is empty. That means there are no elements inside the HashSet by default. Optionally, you can initialize the values inside the HashSet. Suppose these are the values that I am trying to assign. These values are stored based on the index that is generated based on the hash code. The formula for index, as you know already, it is hash code modulo size of the array. The default size of the HashSet is 17. First, we will get hash code of the good morning. Based on the hash code, the index will be generated. In that specific index, the actual value gets stored. I am trying to write a for each loop for the HashSet in order to read all the elements from the HashSet. So from the HashSet, each and every element will be assigned into the variable called message. In this case, the message data type is a string because it is of HashSet of string. So for the first time, message equal to good morning, and you will get the same message in the output. And next time message equal to how are you, and the same value gets printed through the console.writeLine statement. Like this, it goes to all the elements and prints all the values respectively. That means each value will be printed one by one. We have a property called count to count the number of elements inside the HashSet. That gives you actual number of values that you stored currently in the HashSet, not the actual size of the underlying array. As of now, we have 3 values, so count is 3. And you can add additional values by using add method. So I am trying to add another message, for example, good luck. So the count becomes 4 and same value has been printed at last. Notice an important point here. The values may be stored based on the index rather than the insertion order, because the actual storage location or actual storage order depends on the index but not the insertion order. But while retrieving, you always get the values based on the insertion order. That means the first value first and second value next and so on. So always it persists the actual insertion order or initialization order, no matter how they are stored internally behind the scenes. So in the actual storage point of view, we are not sure in which order they are stored. We are unable to get that. For example, I guess have a good day might be stored at the index 0. Good luck may be stored at the index number 1, but we are not sure about that. It depends on the hash code of the particular string. And if the hash code changes, the index position also changes. And also, if the size of the hash set is changed, the index positions vary. That means the indexes will be every time recalculated, every time the size of the array has been changed internally. So irrespective of the internal storage, the actual insertion order will be persisted. So that is the reason through the for each loop, you are reading all the elements based on the initialization or insertion order, irrespective of the storage order or index. And we can remove a particular element by using remove method. Suppose I wish to remove have a good day. So after removing, the count again becomes 3. As you can see, have a good day has been removed. Sometimes you want to remove the elements conditionally. For that cases, we can try using remove where method, which allows you to pass a lambda expression that returns true or false. If you return true, the element will be removed. If you return false, the elements will be kept as it is in the hash set. Suppose you want to remove the element when it ends with u. So I am writing messages.removewhere, and I can supply a lambda expression as argument. And this lambda expression has a parameter that receives each value from the hash set. For example, I name it as m. So this lambda expression executes once for one element. For the first time, m equal to good morning. Next time it is how are you, and so on. Each time you must return true or false. If you return true, that particular element will be removed. But in case if you return false, the element will be kept as it is in the hash set. Suppose I am checking here, if the m value ends with u, then you want to remove by returning true. Because the ends with method returns true if it ends with u, otherwise it returns false. So in case of true, that means if it ends with u, we are removing it, otherwise we are not removing it. So as of now, we can see how are you got deleted, because in case of how are you, the condition is true. So because of remove where, it is being removed here. But sometimes you don't want to remove, but you want to just check to determine whether the particular value exists or not. Suppose you want to search whether the good morning exists or not in the particular hash set. So how can you make sure whether this value exists in the hash set or not? You can search for the particular value based on the contains method. But this contains method is extremely faster because it is not linear search. It recalculates the index based on the specified value. For example, we are looking for a good morning based on that string good morning, the index will be recalculated and it directly goes to the specific index to find out whether the particular value exists or not. So it need not reset all the elements top to bottom. That is the actual benefit of HashSet. So if you have a large amount of data, maybe millions or billions of data, HashSet is extremely faster than others. So we have a method called contains, and here also we are able to specify the value, and here you can supply the value which you want to search. For example, we are searching for good morning. Remember, it is case sensitive. So we are looking for good morning. It recalculates the index based on the hash code of good morning, and it directly goes to the specific index and search for good morning whether it is exist in the linked list at the index or not. In case if the specified value is found, it returns true. In case if it is not found, it returns false. See, in this case we are getting true because the value good morning exists in the hash set. And we also have clear method which clears all the elements from the hash set. That means the hash set becomes empty in case of clear method. And then we also have union with and intersect with methods in order to perform union and intersection operation. Let me show that in a separate application. I am creating two hash set. For example, employees 2021 and employees 2022. So these are the employees as per 2021. So these are the newly joined employees in 2022. Now I want to perform union. That means I want to combine both of these employees, make a single hash set. In other words, I want to add these new set of elements into the existing list. So the target hash set is employees 2021, and I need to supply another collection, that is new employees 2022. The new set of employees of 2022 will be added, that means will be unioned with the previous collection, that is employees 2021. And the union with returns void, so it doesn't return anything, simply it adds all these elements to the previous list. So I am trying to read and print all the elements from the previous list, that is employees 2021. So as you can see, it includes all the elements from the first list as well as the second list, because the union with appends all these elements to the previous list. And we also have another method called intersect with in order to perform intersection. Let me take a separate application for that. So it is the same code from the previous program, but in this case, I am storing the employees as of 2022, whereas Amar and Akhil continue the same. But Samrin has been resigned, so we are not keeping her. And John, Scott, others are the new employees joined in 2022. So I want to perform intersection, that means I want to find out the common names among these two lists. And the positions can be different. Suppose I'm keeping it in the middle of the collection. So I want to find out the common names among these two. That means I want to find out the employees who work in both years, 2021 and 2022. In this case, intersection works. So instead of calling union with, I'm calling intersect with and specify the collection name. So it finds only the common names, that means common elements that exist in both collections. So in this case, we got only Amar and Akhil because only those names exist in both collections. That means indirectly Xamarin has been removed from the first collection. So these are all the various methods exist in the HashSet. So HashSet is a generic class and you cannot get or set the elements based on the key or index. Here you cannot access the specific index. For example, I wish to access the index at 5 or 2 or something. That is not possible. Because the index will be automatically calculated every time based on the hash code of the specific value. So when you are searching for the particular value, it finds out the hash code of the specific value which you are searching, and based on the hash code, index will be calculated and the specific value will be searched at the exact index instead of performing linear search. HashSet allows you only one null value, whereas hashtable allows only one null key. But hashtable allows multiple null values. So in case of hashtable, only one key is allowed, but in case of HashSet, only one null value is allowed. When you are trying to add a second null value in the HashSet, you will get exception. You cannot perform sorting based on HashSet because they are internally stored based on their dynamically calculated index. These are all the features of the HashSet. And these are the properties and methods of HashSet which are demonstrated before a moment. So add method allows you to add the elements. You can remove the element based on the value. You can remove element based on the predicate, and you can search for the particular value to determine whether the particular value exists or not. And you can clear all the elements. You can perform union and intersection. So in real-time applications, when you don't want to store the keys, but mainly you want a collection to determine whether this particular value exists or not, for that cases, we can store those set of elements in the HashSet collection. But alternatively, you want to get the exact element based on the key, for example, employee ID unique key. In that case, prefer using hash table or dictionary. But you want to store a plain set of elements with or without unique key. In that case, prefer using list class. But in case if you want to store key, and in case if you are performing adding and removing process less number of times, but mainly you are trying to retrieve elements by using for each loop or based on the key, in that case prefer using sorted list. This is all about understanding the HashSet in C#.